Testing. Thanks for your kind introduction. So actually, for those who have attended last year's forum, you may see some of these looks familiar, but trust me, I've updated the numbers and some of the arguments which will be slightly different from last year's presentation. But for sake of continuity, so I adopt the same PowerPoint from last year. So actually, I would like to share some of the ideas about this AI and digital infrastructure for a sustainable future. Look at the tale of twin transition. I learned that word from Patrick last year when he was talking about this, mostly from European. So actually, the same slides or similar slides from last year. Actually, one thing which tricked me to try to think about this topic was when I was doing research in data center. One thing caught my attention is during COVID, although our human activity has been changed, you mentioned that we can do activity or behavior change for sustainability purpose, but even if our physical activity reduced a lot, and postmodern analysis realized that the carbon emission of global scale only reduced by 5.2%, which in a statistics model, which probably is margin of error. There's no significant or statistical significance enough reduction in the carbon reduction, although we have huge human activity has been suppressed during COVID. So one idea I thought was maybe look at what happens in the digital activities. So actually it did happen during COVID. The digital transformation has been accelerated and people spend more time online and demand more server, more data centers has been built. Serena has been here. Alibaba is building huge amount of data center to accommodating the digital traffic over the time. Then my thesis would be this one way to explain why there's not significant reduction of carbon emission because of human activity. Then I started to look into, and I also learned from Patrick from last year, this twin transition has been trumped by 2022 EU Strategic Foresight Report. On one hand, we have digital transition, which we move everything online, and actually demands more servers and data centers. At the same time, we're also into this sustainability transition, which we want more reduce the carbon emission. And as a as a computer scientist, I thought, looks like these two have been fighting with each other, but we always want to build a harmony among everything. So I thought, can I find the sweet spot of these two transitions in which I can leverage the emerging technology like AI and data science, such that my AI and data science, which mostly in the digital transition, can reinforce the sustainability rather than make these sustainability challenges worse. So that's my idea, has been driving me to think about this question. So let me start with the one side of story, these AI-derived sustainability challenges. Patrick also mentioned AI costs a lot of energy as well. And probably you read in the news, people like Jensen Huang, some other mentioned, if you would like using current technology to achieve AGI, you would like 13 galaxies of amount of energy to power these data centers. That's actually, he likes to exaggerate a little bit by nature. Let me look at what specifically a more realistic number. So in data center industry, we do keep track or estimate the amount of electricity consumed as a percentage of the global power consumption. Nature in 2020 published a paper to predict that by 2030, normal data center would actually consume nearly 8% of all the electricity in the world, which is about the same as airline industry. That's still okay. And in Singapore, we are small red dot on the earth, but we have more aggressive because we are only industry we have, no, not only that, major industry we have is the digital industry. So we predict that by 2030, we'll consume 12% of all electricity in Singapore. And these are obviously driven by these digital activities like I call ABCD, AI, big data, cloud, and digital transformation. And these predictions are before the current AI disruption happened. So let's look at, with this latest AIGC and large language model, how this number would be transform. Let's just using a simple example. Look at these three important large language model. These three companies built Meta's Llama, OpenAI's ChatGPT 3, and Google's Palm. And we list them in the order of the increased number of parameters. Roughly on x-axis is linear, y-axis on the left-hand side is the energy consumed to train that model. You can see roughly these are linearly grows, and which can be nicely explained by a fact or a parameter in data center called PUE, power usage effectiveness. It's defined as the total power, IT and the cooling together over the IT equipment. In that space, the globally PUE is converging to 1.2, so no one have better advantage against others. So therefore, they are linearly grows. But if you look at the amount of carbon emit for training these models, you see vast difference. These Google guys, although the parameter number is like almost 3 times higher, but its carbon emission is only half of that. Why is that? Can we explain that? Of course. Google, being the market leader in green data center, it has a technology allowed them to run this data center with more green energy. So there's another metric for CUE, carbon usage effectiveness, defined as the total carbon emission over the IT equipment energy. So even you have the same PUE, you may have different CUE. So therefore, you will result in different carbon emission for the same training purpose. Now we're just taking this number to look at how to estimate the global, from a global perspective. Now here, I deviate from my normal computer science view, just adopt a more economics view. Because otherwise I will not get my paper published in computer science, but probably here I can get away with that. So actually, if you look at the AI typically for large language model, you have 2 stages. You have training, you have inference. Training means you use large number of the training model. And then use that model to serve your customers. The way when you interact with the ChatGPT, you are exercising the inference stage. What OpenAI or like other guys in train that model is the training stage. Let's look at the power consumption trend rather than specific number. X-axis is the AI adoption. Y-axis is the energy consumption. So if you look at the training, pretty much training are quite constant. They are because they only limit the number of models over. People will do this foundation training model, so you roughly as constant. But inference, because the more people use the computer or server needs to do more work to serve these people. So therefore, your inference power consumption will grow as your number of people increases. So actually, if you put these two together, you have this upward trend in the total power consumption for large language model. That's the things we want to suppress them. Actually, researchers have been working on this. Like this, one of my research projects, look at this AIDC. You have to unpack this AIDC into different layers, look at what things you can do, try to make this computing process more energy efficiency. But for this audience, I'll skip this page and look at some more wild ideas, how we run the data center using more like green energy. For example, people start to think about using hydrogen to power the data center rather than use the normal electricity generated from natural rich gas or liquid natural gas. So actually, also a previous speaker mentioned about the carbon tax, and using hydrogen to power data center actually is more scalable. Of course, at this stage, the price of hydrogen-generated electricity is much higher than the electricity generated by liquid natural gas. Economics predict by 2030 or 2040, these two prices will meet each other. But at this stage, they're still quite far away. Of course, government always come with ideas. I can use credit or tax, make people to these two price can actually on par to each other. So force people to do this. This one way, actually a lot of companies already start looking into hydrogen power data center. The other, which is, I feel like in the maybe 20 to 30 years of time, I want to see the data center in the space. And think about 20 or maybe 10 years ago when Elon Musk talked about this starting, no one trusted, not being him, right? But in maybe 15 to 20 years' time, we will probably see data center flying over the Earth's orbit, and we can leverage that computing over there rather than on the ground. Actually, we can do a quick little calculation of carbon emission of this data center in this space. You can realize that's a factor of lifespan of the satellite or server. So roughly, if you can get lifespan into like probably 5, 6, 7 years, it actually makes sense to shoot your servers into space and leverage the solar power and the natural cooling over there to run your data center over there. I know EU has been talking about for over the last couple of years, and there are probably plans to actually launch the data center in the orbit. And this will become another possible, because in Singapore, we don't have land. But in the space, it's all equal. So Singapore, probably we can do this. Actually, we are talking to the government, try to fund some research programs to look at the feasibility of running data center over there. Okay, so that's one side of the story, have AI drive the energy consumption. Of course, AI being so omnipotent to solve everything under the sun, right? It should also help me to improve my sustainability, right? Reduce the carbon emission. So then I have thought about what AI can do. So I basically split AI into business AI, in which using AI to address the business process that's not interesting here. So what more interesting is what I call industrial AI, using AI to address the physical space challenges, which are more related to the sustainability. Like look at what I call 4 areas: factories, fields, fleet, and facilities. And for convenience, I call that F4. For those who are in my age, you probably know what that means, right? Sorry about you guys. It's a joke. It's people in my age watch that movie theory and TV theories. And it's possible to do that, right? So back to I use this AI to address the carbon emission in data center. Come across this digital twin to solve that challenges. So I can use this to reduce the carbon emission in the data center. So actually, we take that technology to use for other data centers. We actually can save a lot of energy efficiency, energy consumption. So now I've looked at 2 sides of, one, AI result in carbon emission. Second, AI can help also address the carbon emission in other industries. So now put these things together. Let's look at this, my energy consumed by AI. Assume I've done a good job to actually linearize that line rather than let it upward. And at the same time, the energy saving from AI will grow tremendously. So at a certain point, the benefit of using AI will shadow the cost of using AI. So we thought these are the inflection point. Actually, I'm trying to get some research grants to actually put more categorization of this curve. Then I skip this one. And people ask me, if I want to do AI, what are things need to be paid attention to? Then I come up this thought about how to do AI, how to prepare for AI project or AI strategy. So 5 items I want to look at, starting from just treat AI as a moonshot project. What would be interesting? First, I will need the engine. In our case, it's computing platform. GPUs. I will also need pilot, which is AI researchers. Those are overly priced now. And also we will need algorithm. Okay, as the route, and also we'll need data to fuel this engine. And last one, often forget, is the application. I just mentioned a few ones. So 5 important things. I call that the AI OS product. If you take the first letter of these 5 keywords, not easy for me to remember, but easy for you to remember now, right? The AI OS product, easy, right? And of course, as economics, you always ask, doing AI, can that help my economy, right? So I did some research, not me, but I found some evidence to prove that. Actually, they shown that actually they first defined something called computing power index. They found that 1% of increase in computing power index, the GDP grows 1.8 thousand, And the digital economy grows by 3.5. I don't know what that the numbers mean. Next page is more interesting. I want to make that easier for people like me to understand. Say, if I invest $1 into that industry, how much GDP I can get? On the left-hand side, I see $1 into the AI or IT, digital economy grow by $15, and GDP output is $29. So for those who are economics, maybe you can tell me later, is number high enough or not high enough? But if in Singapore, I want to compare that industry with other major industry in Singapore. IT is 29, and healthcare is 4, semiconductors is 26, ocean economy is 5, and renewable is 8. It's a no-brainer. One should invest more on the AI and infrastructure. So with that, I like to conclude my talk. Maybe during break, we can have more conversation about these ideas. Thanks.